In project analysis, once we have drawn a project network and we have determined the duration of the project and found the early start, early finish times and the late start, late finish times, we become concerned with the identity of the critical path through the project and a highly related concept, slack. You can see that here. Okay, what is this? This is a project that we've been analyzing earlier that belongs to Epic Scenic Studios. We already know that this particular project will take 10 days. That is not what's being asked here. It's being asked, what's the so-called critical path? Now wait, critical path. What is the critical path? Critical path, set of all activities with 0 slack. That is the formal definition of the critical path. You say, oh, well, great, but the next question is what is the slack in each one of the activities? And if I knew that, I could answer the critical path question. True, I mean, we'll handle all of that. The critical path, though, as long as we're talking about that as a concept, is the set of all activities with 0 slack. We'll identify that in a minute. It's not hard. It is also a couple other things that you might want to note. The critical path is the shortest, excuse me, not shortest, critical path is the longest path through the network. The critical path is also the reason that the project is 10 days long. Because we found out in earlier analysis that this project from Epic Scenic Studios, it will be 10 days to finish it. Okay, the critical path, loosely speaking, is the reason it will be 10 days long. Oh, all right, now we still haven't identified what it is. And you say, oh, well, to do that, the theory is you have to find the so-called slack in each one of the activities. Okay, that's easy enough to do. Slack in an activity is the late start time minus the early start time, or, your choice, the late finish time minus the early finish time. Slack in an activity is nothing more than the difference between those two sets of timings that we found in the earlier part of the analysis. So we would do that computation for each one of the tasks, and we've actually been asked to do that. All right, well, I'll make a little table here. Let's see, A, B, C, D, E, F, G, H, and I, right? I want to find the slack in each case for each one of these. I could use either early start, early finish, or late start, late finish. It looks like in my notes, I'm just drawing some lines here so that I keep things straight. Looks like I used the start times. I compared the start times. Now, in saying that you can use either, bear in mind what that means is you get the same answer either way. If you say, oh no, I get different answers, that tells you there's something wrong with your math. You've made a mistake someplace. Now, in my notes, what I used was LS minus ES. Okay, but this works just as well. Because what is the slack in activity A? What you do is you say, all right, look at the start times. The late start time for A is 0. Okay, minus the early start time for A is 0. Oh, the slack is 0. Well, that's not very interesting. Well, hang on to that thought. Now, for B, the late start time is 2. The early start time is 0. So there's a slack, we say in activity B, a slack of 2 days in there. For C, the late start time is 1. The early start time is 1. There's another one where the slack is 0. We say there's no slack in that activity. For D, the late start time is 5. The early start time is 3. There's another instance of 2 days worth of slack. For E, the late start time is, oh goodness, 8. That's late. The early start time is 1. There's a lot of slack in that activity, 7 days. For F, the late start time for F is 5. The early start time for F is 5. Here we have no slack. For G, the late start time is 7. The early start time is 7, so there's no slack there. For H, the late start time is 8. The early start time is 8. There's no slack there. And I, the late start time is 9. The early start time is 9. There is no slack there. Okay, here is the table in which we have addressed this question right here. We found the slack in each one of the activities. It did ask what's the critical path. We would review our work for, let's see, who doesn't have any slack? A, C, F, G, H, I. That is the critical path through that network, of which actually that was highlighted in this note frame the entire time. Do you notice that? A, C, F, G, H, I. A path is any route from start to finish. And if you connect those particular letters, they connect perfectly one path from start to finish. That is the path that is 10 days long, that loosely speaking is causing this project to be 10 days long. Now it asked us for the slack in each one of the activities, so it was good that we made that table and we actually calculated each one of them. If you only need to know the critical path, right? You just want to know that, and that's all. Yeah, you didn't really need to calculate the slack exactly for each one of the activities, because do you notice it's highlighted up here? Since the critical path is the set of activities with 0 slack, that means that when you're looking at your work, you're looking at the network, it's the activities in which the early start times and the early finish times match. You can see where the critical path is without doing any additional arithmetic. It is right through there. We can't necessarily see and had to calculate, what is the slack in the non-critical path activities.